All right, good morning, everyone. We are going to be talking about today general transformation of functions. Okay, there are different type of transformation. Okay, number one is reflection. Okay, what do you mean by reflection? It could be a reflection over x-axis or over y-axis, which just means flipping of a function over the x-axis or over the y-axis. If we assume that is x-axis and we draw our function right on top on the positive side, on the positive side of the y-axis, if we reflect that over this mirror, which is the x-axis here, we are going to have that mirror image. All right. So what is reflection over x-axis in algebraic notation? Or is going to be y equals to negative function of x. So the negative is right directly at the front of f to indicate reflection over the x-axis. Okay. Now, if we assume this is a y-axis, I will draw our graph on the right-hand side. This graph can be flipped to the other side through this mirror indicated by y-axis to get that graph. Okay, that we can also indicate reflection over y-axis algebraically by writing y equals to function of x. The negative sign will be directly at the back of x. Be careful, these two are different. This one is directly in front of f, function of f, but this one is directly in front of x inside the parentheses. Okay, now another type of transformation is dilation. So dilation just simply means change of size but maintaining the same shape, right? We have the shape here, right? Shape of a quadratic function here. If we draw this function, we can uh, uh, dilate this quadratic function along the y-axis. Okay, it can also be dilated along the x-axis. If you dilate along the y-axis, it become narrowed. It become narrowed. The graph become narrowed. All right, and it can be indicated algebraically by multiplying letter a right in front of function of x. All right, and this particular case can only happen when that letter a is greater than the value of 1. It could be 1.2, 1.5, it could be 20, it could be as big as possible, but must be greater than 1. Now another type of dilation is a dilation along okay, before I talk about dilation along x-axis, we also have another type of dilation along the y-axis. When you try to compress the graph along the y-axis, it becomes widened, and it can be represented by the simple equation y equals to a multiplied by its function of x. Right, the a is right in the front of f, and remember, a must this time around must be less than 1. So another type of translation is dilation along the x-axis. Okay, the first one is you're compressing horizontally. Compressing horizontally, see that along the x-axis, the graph become narrowed. All right, it can be represented algebraically by equation y equals to function of x. The b is multiplying the s directly right in front of s inside a parenthesis. At this case, b must be greater than 1. B can take the value of 1.1, 1.2, 1.3, 1.4, 2, 3, 4. Okay, as long as it's greater than 1. All right. So that another type of dilation along the x-axis is the one that is horizontally stretched. When you stretch a graph horizontally, it becomes wide enough, and the equation for that will be y equals to function of x with the b multiplying the s directly inside a parenthesis. And this case, b must be less than 1. Whenever you have a b less than 1, like 1 over 2, 0.2, then you know that horizontal stretch has happened. The third type of transformation is translation. The translation along the x-axis. and the translation along the y-axis. And how does that happen? The first one is the graph can decide to shift left along the x-axis, and that can be represented by y equals to function of x plus h. Remember, we are adding a number. H represents a number. Right inside the parenthesis directly to x. We're adding a number directly to x inside a parenthesis. Remember, this number is added. It's not subtracted, added, plus sign, added. Then the graph will shift left. If the graph must shift right, then you will need to subtract h. The h is a number, right? Remember, there's a minus sign between s and h inside the parenthesis. We should not mistake this. We should not mistake this, right? We go to left, it's a plus. We go to right, it's a negative here, okay? Now let's look at translation along the y-axis. It could be the graph could either move up or down. When it's moved up, we have a algebraic equation of y equals to function of x plus k, okay? Remember, here the k is outside the parenthesis. The k is outside the parenthesis as contrasted, as different from in the case of translation along the x-axis where the h is h, letter h, which is inside the added inside the parenthesis. Okay, now look at this case down. When the graph move down, we have y equals to fx minus k. Again, there is a negative sign here showing that there's a movement of the graph down the vertical axis. Okay, all right, here a plus sign shows the graph move up. If you compare this with that, you can see that when it was plus in the x-axis movement, it was left hand side movement. When it is a negative on the x-axis movement, it is movement to the right. But in the case of y, it's kind of different, right? When it is plus, it is up, movement up. When it is negative, it's movement down. This must be taken care of and always be remembered and not confuse these two together. Okay, let's put the whole thing together in one simple formula. Let's assume we have a parent function which is y equals to fx, function of s in function notation. Okay, this function of s could be a quadratic function, could be cubic function, could be linear function, could be any type of function. All right, so when we transform this parent function, we are going to get what I personally call a child function. All right, a child function. When we transform, most of the time, we might not have all this transformation at once going into the parent function. Sometimes we might just have only one or two or just three or maybe probably all of them put into the parent to produce the child. But in this case, we're trying to just explain by showing the example of all here are all put into the parent function to get all the, again I repeat myself, it's not all cases that you can have all of this happening at the same time. We might just have only one happening or two happening. Okay, so take note of that. So let's look at how the whole thing was put in here. Okay, now negative sign directly at the front of function of x here indicate a reflection over the s-axis, right? A reflection over the s-axis. Okay, and the negative sign right in the back inside the parenthesis right in the front of x, okay, here is a reflection over the y-axis. Okay, it's an indication of reflection over the y-axis. And the letter A, as I've said earlier, okay, could either be less or greater than 1. If it is greater than 1, we are going to be having a vertical stretch along the y-axis, meaning a narrowed graph, okay? When this particular A is less than 1, you're going to have a vertical compression, a widened graph, okay? Now let's look at B, placed directly inside the parenthesis in front of X. When the B is greater than 1, we are going to be having horizontal compression. In other way around, we mean a widened graph, okay? A widened graph as you see here, widened graph as you see here. And also when you have B less than 1, you're going to have horizontal stretch, a narrow graph as you see right here. Okay, so when you have a plus h, you're going to be having a shift to the left along the x-axis. Okay, when you have a negative h, you're going to be having a shift to the right by the amount h. Remember again, the h is just a number. Okay, it could be 1, it could be 2, it could be 0.1, it could be any number. Okay, all right. Now let's look at k here. All right, when it is plus k, when k is added, you're going to have a shift up along the y-axis by k. All right, when the k is subtracted, negative sign, negative k, you're going to have a shift down by k. Again, k is a number. It could be either 2, 3, or 0.1, 0.2. All right. So this is all about the transformation of function. With this simple formula, we can address any type of transformation of any function that we can ever come across in algebra. Thank you for watching and listening.